Hello all, welcome you all to the class of detail electronics KV 039/049. Myself Dr. Kishanu Kundu, Assistant Professor, Department of Electronics and Communication Engineering, GL Bajaj Institute of Technology and Management. So, we are in lecture number 15 and we are discussing about flip flops. In the previous lecture, we have discussed about SR flip flop and SR latch. So, in this video we are going to discuss about rest of the flip flops, those are JK flip flop, D flip flop and T flip flop. So, let us begin today's session. So, these are the table of content of today's video. We will be discussing in detail about JK flip flop, master slave JK flip flop, D flip flop and T flip flop. So, first JK flip flop. So, JK flip flop is, you can see from the structure itself, we have already discussed about SR latch, SR flip flop. So, here one part is SR latch, you can see this part is nothing but SR latch. Okay. So, again with the SR latch we are using two more NAND gate, right. So, JK flip flop I can tell in brief that the basic SR NAND flip flop circuit has many advantages and uses in sequential logic circuits, but suffers from two basic switching problems. First one, if the set is 0 and reset is 0, means if S and R both are 0, then it should be avoided. Okay. And if set or reset change state while the enable input is high, the correct latching action may not occur. So, due to these two disadvantages, we go for next type of flip flop, that is JK flip flop. Okay. So, here we have written, then to overcome these two fundamental design problems with SR flip flop design, we use JK flip flop, and inventor of JK flip flop is Jack Kilby. Okay. So, you can see from the diagram itself, we are having one SR latch, this is nothing but SR latch, and what we have done, we have used two more NAND gates, and the output Q output is connected to the second NAND gate as input, and Q bar is connected as input to the first NAND gate. Okay. So, let us go into detail. So, JK flip flop is basically a gated SR flip flop with the addition of a clock input. In SR flip flop there is no clock input, but from JK flip flop onwards we will implement the use of clock. That is about the clock we have already discussed in previous lectures. So, you can refer there. So, that prevents the illegal or invalid output condition that can occur when both inputs S and R are equal to logic 1. So, we have seen in SR latch and SR flip flop, when both the inputs are 1, that output will be invalid, right. So, to avoid that we use clock signal. Due to this clock signal input, JK flip flop has 4 possible input combination: logic 1, logic 0, no change and toggle. So, let us start. Again from this diagram you can see this is nothing but the SR latch, SR latch. So, what will be the truth table of SR latch using NAND gate, already we have checked in previous slides. So, let us discuss once again. So, this is SR, this is Q and Q bar. So, 4 conditions 0 0 0 1 1 0 and 1 1. This is nothing but the truth table of SR latch. We already discussed this in previous lecture. So, here you can see when both are 0 0, then it is not used or invalid, you can say not used or invalid. When 0 1, it will be 1 and 0, for 1 0 this will be 0 and 1, and for 1 1 the condition will be memory, for 1 1 this can be memory. So, this is the truth table of SR latch. This will be using when we are going to check the truth table of JK flip flop as well. So, you can see here clock one input is J and one input is Q bar, this is nothing but Q bar, and here one input is clock, one input is K and one input is q, right. So, now we will go further. You can see if I can write like this. So, when let us check from here. Okay. So, let us start with the truth table of SR latch. Okay. So, SR we have already seen, this is q and q bar 0 0 0 1 1 0 and 1 1. So, when both are 0 0, then that is invalid case. When both are 1 1, then it will be memory, and when 0 1, there will be 1 0 and 0 1. So, this is nothing but the truth table of SR latch. Okay. So, now already I have seen that in JK flip flop this part is SR latch, this is nothing but the SR latch. Okay. And to avoid this condition 0 0 both are output are invalid. So, that case we are avoiding in JK flip flop. So, we have included one extra input as clock. So, here let us name as this is NAND gate 1, 2, 3 and 4. Okay. So, when clock input is there and both are J and K input, then again finally you are getting two output Q and Q bar. So, let us write like this Q and Q bar. Okay. So, first condition when clock is 0, first condition is when clock is 0. We know that in NAND gate if any of the input is 0, output will be 1, right. So, if clock is 0, then if clock is 0, then output of NAND gate 1 and 2 both will be 1, both will be 1, and if 1 and 1 is input to the SR latch, then the output would be memory, clear. So, here when clock is 0, we will not depend on the input of J and K, and you can see here that Q bar is connected as a input to the first NAND gate and Q is connected to the second NAND gate as input. Okay. So, we will not bother about whether J or K is 0 or 1, no, we will just if we see clock is 0, we can check that output of 1 and 2 NAND gate will be 1 1 and it is the input to the SR latch. So, 1 for 1 1 the SR latch output will be memory. So, in this case we will be getting memory. Next state will be same as the present state. Okay. So, here you can see not depending on J and K, we can see that this is memory, clear. Now, next clock is 1, from now onwards we will consider clock as 1 and we will be having 4 condition of J and K 0 0, 0 1, 1 0 and 1 1. Okay. So, when clock is 1 means this is 1 and J and K both are 0, clock is 1, J and K both are 1. So, sorry both are 0, first condition when clock is 1 and both J and K are 0. So, again the same rule, if any one of the input of a NAND gate is 0, then output will be 1. So, here also the output will be 1 for NAND gate 1 and 2, and if 1 and 1 is the input of a SR latch, the output will be memory. So, in that case also the next state will be same as the present state. So, here we can see that this is also memory. Got it up to this? Now, when clock is 1 and J is 0 and K is 1, next is J is 0 and K is 1. So, if J is 0, so we will not bother about what is Q bar and what is clock, no, if one of the input is 0, we can say the output is 1, and if this is 1, then we can say the output of Q and Q bar will be 0 and 1. Okay. This will be 0 and 1. Like that, if J 1 and K 0, next is J 1 and K 0, in this case also J 1 and now K will be 0, J is 1 and K is 0. So, this will be output will be 0, but we cannot say that this is 1. So, if this is 1, then we can like that we can get the output as 1 0. Okay. This will be the output as 1 0, and the last and most important case, clock 1, J 1 and K 1. So, here we cannot clearly say that what will be the output of NAND gate 1 and 2, this is very confusing. So, in that case we will be consider, let us consider Q as 0. If Q as 0, then see all 3 are 1, means this will be 0 and this will be also 0. So, if 0 0 is input, if 0 0 input, so this here it is invalid, okay. But here we can check if Q is, again we will check Q as 0, then it will be going to this. So, it will be as 1, now it will be toggling, the output will be changing. So, the output will be considered like that, Q will be like this 0 1 0 like that, it will be changed, it will change like this, and Q bar will be also like this 1 0 1 0 like this. So, this will be considering, and this will be the output, this will be the output. So, this fast changing is called toggling, and this is also called as race around condition, this is also called as race around condition. So, this is the main point, the toggling. So, we can now whatever I have told you, I have written like this. See, when clock is 0, our input of J and K does not matter. So, out next state will be previous state, means memory, this is nothing but memory. When clock is 1, J and K is 0 0, in that case also the next would be same as the present state, means memory, Q n plus 1 will be Q n. When clock is 1, J and K 0 and 1, then next state will be 0, for 1 0 it will be 1, and when all inputs are 1, the last condition, when all inputs are 1, that Q n plus 1 will be Q n bar, means this is toggling, this is toggling. Clear? Now, this is the final truth table, this is the final truth table. So, from final truth table we will be making the characteristic table. You can see this is, I have made the format of characteristic table. So, we will just look at the final truth table, and from this we will build up the characteristic table. So, let us check when Q n 0, see 3 input Q n J K. So, total 8 combination 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 and 1 1 1. So, here when J and K 0 0, when J and K 0 0, Q n plus 1 will be same as Q n. So, Q n plus 1 here same as Q n. So, here Q n is 0. So, this will be 0, got it. Just we will check this table and we will format this table. So, now when J and K 0 1, we can say the output will be, next state will be 0. So, we will be write that like this, then 1 for 1 0, the next state will be 1, we will write that. Now, for 1 1, so when J and K both are 1 1, the next state will be Q n bar. Let us check very sincerely, when both are J and K both are 1 1, the next state will be Q n bar, means the toggling of the next state, complement. So, here Q n is 0, now Q n bar will be 1, this is very important, this is nothing but Q n bar. Okay. Now, again for 0 0 we can check when both are 0, the next state will be same as the previous state, means Q n, here value of Q n is 1, so we will write as 1, right. Next for 0 1 we will be having 0, from 1 0 we will be having 1, again for 1 1, for 1 1 condition next state will be the toggling of previous state Q n bar. So, here Q n is equal to 1, so Q n bar will be 0. Is it clear to all of you? So, the final characteristic table is 0 0 1 1 1 0 1 0. Okay. So, now we will make K map from this. Okay. So, let us do that. One more thing, from the previous table, this table will make a characteristic table we have already done. So, we will now build a excitation table, excitation table. So, for excitation table the inputs are Q n and Q n plus 1 and the output is J and K. So, the 4 combination 0 0 0 1 1 0 and 1 1. So, now we will check the previous table and format this. So, in the previous table, see, one second, we will erase like this. So, it will be easy for you to understand. Okay. So, now let us check. So, for q n and q n plus 1 0 0. So, let us check here, when q n 0 and q n plus 1 0, again here also q n 0 and q n plus 1 0. So, these two cases will be considered. So, here q n 0 and q n plus 1 also 0, q n 0, q n plus 1 also 0, but here j is 0 in both the case, but k is first time it is 0 and second time is 1. So, j is 0 for both the cases, but k is 1 and 0, it is different. So, like that you can write here, you can write j is 0 for both the conditions, but k is not static. So, it will be let us cross 0 cross like that. Next, what condition will be there, 0 or 1. So, let us check q n 0 and q n plus 1 1. Any other condition here? Any other condition? Yes, here also 0 and 1. So, here see j is 1 for both the case, but k is changing, first time it is 0 then 1. So, we can write like this 1 and cross, got it. Now, similarly 1 0, let us check 1 0 means this condition q n 1 and q n plus 1 0, 1 0, and here also 1 and this is 0. So, here k value is 1 for both the cases, but j is now 0 and 1. So, we can write like that cross 1, because k is 1 in both the cases, j is changing, right, and the last case 1 1. So, just check when both are 1, q n this one and q n plus 1 also 1, q n 1, q n plus 1 also 1. So, here both the cases k value is 0, but j is changing. Okay. So, we can write like this, j is changing and k is 0. So, this is very important, the excitation table. So, already we have made 3 things, final truth table, and from that we have made characteristic table, and from that we have made the excitation table. Now, we will be making k map, and k map will be built on the characteristic table. So, characteristic table, there are 3 inputs q n, j and k, and we will make the k map for q n plus 1. So, let us start. This is for q n plus 1, okay. This is nothing but q n and j k. So, 4 combination 0 0 0 1 1 1 1 0 and 0 1. So, from this characteristic table we will fill up the gaps. So, it will be 0, it will be 0 0 1 1, and here it will be 1 0 0 1 1 0 0 1. So, one grouping will be this and second grouping will be this. So, from this grouping we will be having q n bar j, and for this grouping we will be having q n k bar, q n k bar. So, the final design equation of j k flip flop will be q n plus 1 will be q n bar j plus q n k bar. This is the final design equation for j k flip flop. Clear to all of you? Now, the question is, there is a problem of toggling, that is called race around condition in j k flip flop. To solve that problem, we implement master slave j k flip flop. So, now we will be going to discuss the master slave j k flip flop. Okay. So, see, the master slave j k flip flop is basically 2 gated SR flip flops connected together in a series configuration with the slave having an inverted clock pulse. See, clock is given to the first SR flip flop and the in complemented form, this complemented form means here clock and this is clock bar, the inverted clock pulse or complemented form is connected to the next set of SR flip flop. So, this is the first SR flip flop and this is the second SR flip flop. This SR flip flop is known as master latch and this is known as slave latch. Okay. So, clock is directly connected to the master one and the complemented form is connected to the slave part. Okay. So, we can see that the output from Q and Q for the slave input are fed back to the inputs. Here Q bar will be there, from will be feedback to the first input, okay, and the master with the output of the master flip flop being connected to the two inputs of the slave flip flop. Okay. Means the output of slave flip flops are giving as a feedback to the first one, then master one. Okay. So, let us discuss the working of master slave JK flip flop. The input signal J and K connected to the gated master SR flip flop, which locks the input condition while the clock input is high at logic level 1. As the clock input of the slave flip flop is inverse, means complement of the master clock input, the slave SR flip flop does not toggle. Mean when master is working, slave will does not work, right. At a time only single flip flop will be working. So, the output from the master flip flop are only the seen by the gated slave flip flop when the clock signal goes low, the logic level 0. Next, when clock is low, the output from master flip flop are less, any additional changes to its inputs are ignored. The gated slave flip flop now responds to the state of its input passed over the master section. Means when clock is 1, then master will be working, when clock is 0, then the slave will be working. Then on the low to high transition of the clock pulse, the input of the master flip flop are fed through the gated inputs of the slave flip flop, and on the high to low transition, same inputs are reflected on the output of the slave, making the type of flip flop edge or pulse triggered. Okay. This is very important. We know that there is two type of clock pulses, changing, triggering, level triggering, edge triggering. So, here it is discussed. Then the circuit accepts input data when the clock signal is high and passes the data to the output, the falling edge of the clock signal. In other words, the master slave JK flip flop is a synchronous device and only passes the data when the timing of the clock signal. Okay. Next is D flip flop. Already we have studied the SR flip flop. So, D flip flop is made from the SR flip flop itself. Okay. So, you can check that the main disadvantage of SR NAND gate flip bisabbatical circuit is that the indeterminate input condition set 0 and R 0. When both are 0, then the output will be invalid. That is the biggest disadvantage of SR flip flop. So, to overcome that, we can use the D flip flop. The state will force both the output to be logic 1, overriding the feedback latching action on whichever input goes to logic level 1, first will lose control, and while the other input signal still at logic 0 controls the resulting state of the latch. Okay. But in order to prevent this from happening, an inverter can be connected between the set and reset. Now, we are connecting an inverter, a NOT gate in between the set and reset. Okay. So, this will produce another type of flip flop, it can be known as data latch, delay flip flop, D type bistable, D type flip flop, or just as D flip flop. These are the various names of D flip flop. So, now we will see the D flip flop. See, this is the diagram of D flip flop, it is nothing but this is the SR flip flop. This diagram is SR flip flop. Here this is S and R, but what we are doing, one input D is connected directly to S and its complemented form means with an inverter is connected to the R. The complemented form is connected to the R. So, let us check the output of this. So, SR we know that 0 0 0 1 1 0 and 1 1. So, Q. So, when both are 0 then invalid. Next we will having 1 0 and memory. So, now when we will be giving as D input, see now when is clock input is there, okay, D, and there will be the next state q n plus 1. So, what will be that? If clock is 0, when clock is 0 we know if its clock is 0 then any one input of the NAND gate is 0, the output will be 1, right. So, in that case q n plus 1 will be the memory. So, it will be Qn. Now, when clock is 1 and D is 0, when clock is now clock is 1 and D is 0, means first NAND gate having input as 0 and second NAND gate having input as 1. So, for 0 1 we will be giving as the, this is now like this. So, here we will be getting as, if this is 0 means the output is 1 and this will be 0. So, for 1 0 we will be having Q as 0. So, here will be 0. Okay. And for next, when Q clock is 1 and now D is 1. So, here it will be giving as 0. So, for 1 and 0 the tail would be, this is 1. So, for that we will be getting Q as 1. So, we can say that the next state is that Qn plus 1 is 0 for D is equal to 0 and Qn plus 1 is 1 for D is equal to 1. So, we can say that now Qn plus and D like that, we can finally we can say like this Qn plus 1. So, 0 0 0 1 1 0 and 1 1. So, we will be getting as 0 1 and 0 1, means Qn plus 1 is same as D. This is the final equation for D flip flop. Okay. Here it is again, we are doing like this, already we have done. So, this will be 0 0 0 1 1 0 1 1. So, we can check that same thing will be happening 0 1 0 1. So, we can say that Qn plus 1 will be D. This is the final equation for D flip flop, and already I have discussed this, that when clock is 0 D is not counted. So, Qn plus 1 will be the previous state, means memory. When clock is 1 D is equal to 0, then Qn plus 1 will be 0, and when clock is 1 D is 1, then Qn plus 1 will be 1. Okay. So, this is the D flip flop. Now, the last topic of today's class, T flip flop. T flip is the toggle flip flop, because it is of a toggling operation. Already we have discussed the JK flip flop, and here same input is connected to both the J and K flip flop. This is the working principle of T flip flop. Already in this session only we have discussed JK flip flop, but here you can see the JK flip flop we have discussed. See, this is the JK flip flop. Okay. Now, same input is given to both the NAND gates. Okay. So, let us check T flip flop. So, here we can see like this is JK and this is Q and Q bar. So, same input T is given to both the input, and one more is clock, So, same. So, from the truth table of JK flip flop we can check the output of this. So, let us see, just go through the JK flip flop truth table. So, we know that when clock J K Q n plus 1. So, we will be having clock 0 cross cross, then it will be memory, clock 1 this is 0 0, again it will be memory, and for clock 1 we will be having 0 1 1 0 and 1 1. So, we will be having like this. For last one we will be having toggling Q n bar, and this will be having 0 and 1. Okay. So, this is the truth table of JK flip flop. For that we will be mapping the truth table of T flip flop. So, when clock is 0. So, clock is 0 means for that we will be having Q n, already you have written Q n. When clock is 1, and T is 0, means now both the input are 0 to the JK flip flop. So, both are input are 0, in that case also will be having both the input of JK flip flop is 0, in that case also we will be having next state as equal to Q n. So, this is Q n. When clock is 1 and T is 1, now we will be having T is 1 in both the cases, J and K both are 1. So, clock 1, J and K both are 1. So, in that case the next state will be the toggle version. See, now it is written as Q n bar. Okay. So, from this table we will now like this. So, T is 0, when 0 0, so it will be having as clock 0 Q n 0. So, T is 0 means Q n plus 1 is Q n means 0. Now, T is 1 and Q n 0, T is 1. So, Q n plus 1 will be the toggle version, that Qn bar. So, it will be 1, same like this will be 1 and this will be 0. So, this is the final question. So, will be like that, will be taking as, so t value will be 0 1 1 0, 0 1 1 0. So, finally, we can write the equation like that, Qn plus 1 will be Qn plus 1 will be Qn XOR t. This is the final decision equation from this table. Okay. So, these 2 3 flip flops we have discussed, JK flip flop, D flip flop and T type flip flop. Thank you.